This is Mallikarjun, working as assistant professor in the department of IARE. Today we are going to discuss about the DC response of a series RC circuit. DC response of a series RC circuit. That is, just I am taking a combination of elements called resistor and capacitor in a series. I am giving a DC excitation to it. As we are studying this particular topic in case of a transient analysis, I will have a switch in case of that particular circuit, and I will try to analyze the behavior of that particular combination when the switch is open and when the switch is closed, and what is the transient response obtained, what is the voltage across each element, what is the power flow across each element. We will calculate all these parameters in this particular topic. Coming to the circuit diagram representation of a series RC circuit. As we know that I need an element called R and another element is nothing but what? C, R, C, and I need to give a DC supply. We know that DC supply has generally two polarities, a DC voltage, and this is C, this is R. And as I am trying to calculate or analyze the behavior of this particular circuit for a transient response, I need to connect a switch here. Let me say that initially the switch is open. Initially the switch is open. So we are trying to analyze the behavior of this particular circuit under two switching operations. One is just before closing the switch, that is when the switch is open, and one is after closing the switch, that is when the switch is closed. We are trying to analyze the behavior of this particular circuit under different switching conditions. So this is the circuit diagram whatever I have considered, where R is the resistance offered by the circuit and C is the capacitance offered by the circuit, and the input voltage, as I need to give the DC response here, I am giving a DC voltage where the voltage is represented as capital V, and I am representing the switch with the help of an S. So the capacitor in the circuit is initially uncharged. As we know that as the supply is not at all given and the switch is opened in the circuit, the capacitor which is connected in the circuit, the capacitor will have two things. One is charging and another one is what? Discharging. Initially, as the switch is open, the capacitor is completely in a discharging mode. That is, it is not at all charged and it is in series with the value of a resistor. Now I am trying to close the switch at t equal to 0. Try to close the switch at t equal to 0 in order to represent the complete solution of a current. Let me show you the diagram. So this, I have taken a switch like this. I have connected a resistor and capacitor in series, and I have given a voltage of V, that is a DC voltage. This is R and this is C. Now at t equal to 0, I am trying to close this particular switch like this. Now the switch S is closed at time t equal to 0 plus. Now in order to calculate the value of total current that is flowing into the circuit, as the switch S is closed, I can calculate the value of a current. As we know that all the elements are connected in series, the current flowing in the resistor and also capacitor will be same. Now I am trying to calculate the value of a current in this particular circuit by applying KVL. You know that by applying KVL in this particular loop, you will get the value of, you know the expression for what? Voltage across the resistor VR is nothing but what? I into R. VC equal to 1 by C integration of I dt. So if I am trying to apply the value of KVL in this particular loop in order to calculate the expression for the current, the expression will be V equal to VR plus VC, where V is the total voltage that is applied to the circuit, VR is the voltage across the resistor that is connected in the circuit, and VC is the voltage across the capacitor that is connected in the circuit. Now by using that particular expression, I am trying to rewrite the expression as V equal to VR plus VC as, just substitute the value of VR as I into R and VC as 1 by C integration of I dt. So this is the expression I got for the total voltage as IR plus 1 by C integration of I dt. Now what is my ultimate goal? I am trying to calculate the complete solution of current, that is DC response of a current from a particular circuit. But here I have got the expression for the value of voltage. Now in the next step, just I will take the differentiation of the above equation. So what is this particular voltage? This particular voltage is an DC voltage. DC voltage will be always constant. It is not at all variable. Hence differentiation of constant is nothing but what? It will give you a value of 0. What is the next step? Differentiate with respect to t. 0 equal to I into r plus 1 by c integration 1 by c into I equal to 0. Di by dt equal to 0. By using this particular expression, by rewriting the same expression, I am going to get this particular expression as di by dt plus 1 by rc into I equal to 0 is the equation obtained after differentiating the expression which I got from applying the KVL for the above loop. So this is the expression which I got earlier. After differentiating this equation with respect to t, I am going to get the final expression as like this: di by dt plus 1 by rc into I equal to 0. So by seeing the expression, I can clearly state that the above equation is completely a linear differential equation with only one complementary function. Where the particular integral of the given expression is completely zero. So you know that the solution for the above linear differential equation will be, in general, according to the mathematical terminology, is given as what? I equal to c into e to the power of minus t by rc. I equal to c into e to the power of minus t by rc, or else the same expression can also be rewritten as I equal to c into e to the power of minus t by tau, where the value of tau is rc. It is considered as time constant. It is considered as what? Time constant. Tau is represented as time constant of a series RC circuit. How I got this particular expression or complete solution for the current here? By taking the linear differential equation approach. So the solution for the above linear differential equation approach in general can be considered as I equal to some constant c into e to the power of minus t by rc. E to the power of minus t by rc, or else I can replace the value of rc as what? Tau, where tau is considered as a time constant. C is nothing but a constant that need to be determined. So if I want to evaluate the complete value of current, I need to determine this particular time constant which is represented in this particular expression, that is nothing but what? C. Or else you can write the same thing with respect to K also. Right? Coming to the next thing. In order to calculate the value of that particular constant which is obtained in the solution, that is I equal to C into e to the power of minus t by rc. If I want to calculate the value of I completely, first I need to determine this particular constant C. So in order to use that particular expression, now I am going to use the switching conditions. In a transient response of RC circuit, when the switch S is closed, as the capacitor will never allow the sudden changes in the values, it is the main property of a capacitor. It opposes the sudden changes in the value of voltage. It acts as a short circuit. Then what is the element that is present in a circuit? You can see here, when the switch S is closed, there is a presence of resistor and also a capacitor, and I need to give a DC voltage source like this. But when the switch S is closed, I need to have certain amount of current, but the current flowing through this particular capacitor will be 0 and voltage will be 0. Voltage 0 is nothing but what? It should be represented with a short circuit. Now what is the element that is present in a circuit? Now it is purely acting as a resistive circuit. If it is a resistive circuit, what is the current flowing in this particular circuit? I is equal to V by R. That is at t equal to 0 plus the current flowing in the circuit is considered as I equal to V by R. Now you see here, just substitute the value of C as V by R. Now the expression for total current can be obtained as I equal to V by R into e to the power of minus t by RC, or else it can also be written as V by R into e to the power of minus t by tau. So in order to evaluate the value of this particular value of C, just I am using the final condition, that is switching operating conditions. At t equal to 0 plus, what is happening in the circuit, how capacitor is behaving in the form of a short circuit, and what is the current obtained in that particular thing. Just substitute the value of that particular C in that, you are going to get the final value of the current, that is I equal to V by R into e to the power of minus t by RC. Now just I want to draw the graphical representation of this exponential factor which I got into e to the power of minus t by RC. If I want to represent same thing in the form of a graph, how that response is going to obtain, just I want to represent with respect to different time constant. So in this solution, the quantity RC is constant and is denoted by what? Tau. Now just I want to change the value of a time in terms of TC. So after 5 time constants, that is after time constant, the curve reaches 99% of its final value. After reaching the 5 time constant, you can see here that curve is automatically reaching the final value here. We can find out the voltage across each element by using the current expression. Now I know the value of a current, that is the complete solution of a current for a DC response of a series circuit. What is the current obtained? I equal to V by R into e to the power of minus T by RC. So by taking the value of I into consideration, now I can calculate the value of a voltage across each element that is present in a circuit. So in order to calculate the value of voltage across resistor, I can take this particular expression, that is VR equal to I into R. In the similar fashion, I can calculate the value of capacitor voltage also. So I am trying to calculate the value of VR, that is voltage across resistor. I know the value of I already, V by R into e to the power of minus T by tau into R. So what is the expression for voltage? V into e to the power of minus T by RC is the expression for voltage across the resistor that is connected in a circuit. Is the expression for the voltage across the resistor that is connected in the circuit. In the similar fashion, you can calculate the voltage across the capacitor that is connected in a circuit. So you know that the expression for the capacitor voltage is Vc equal to 1 by C integration of I dt. You know the value of current. I value is V by R into minus T by RC into dt. As we know that V by R in general, it is considered as a constant. V by RC into what is the integration of this particular parameter, that is e to the power of minus T by RC. It is written as some internal factor into minus e to the power of T by RC. This is minus RC plus some constant to C. Or else I can also read it as minus V into e to the power of minus RC plus some constant to C. So this is the expression for the voltage across the capacitor that is present in a circuit. Voltage across the capacitor present in a circuit. Similarly, if you want to calculate the value of this time constant which is present here, that is nothing but there is one more constant that has been obtained after applying the integration for this. So in order to evaluate this, just I need to consider one more switching condition at t equal to 0 plus. As we know that at t equal to 0 plus, voltage across the capacitor is 0. If voltage across the capacitor is 0, automatically this total voltage will become how much? It will become 0. Then what about the value of C? C equal to some V. Then voltage across the capacitor, here it is considered as what? Vc equal to V plus Vc equal to minus V into e to the power of minus T by RC. Then what is the value of C? It is considered as V. It is considered as V. Then take the common parameter here, V into 1 minus e to the power of minus T by RC is the voltage across the capacitor for the given circuit. Voltage across the capacitor for the given circuit. Now we will move to some other expressions. Here I am trying to calculate the value of a power. So if you calculate one parameter called current, you can calculate the value of voltage across the resistor, power that is present across the resistor. Similarly, you can calculate the voltage across the capacitor and also the power flow in case of a capacitor. You know that the general expression to calculate the value of power is what? V into I. But as I am trying to calculate the value of power across resistor, VR into I. You know the value of VR already, you have been evaluated in the last slide, that is voltage across the resistor. Just substitute all those parameters. V into e to the power of minus T by RC into what is the value of current? V by R into minus T by RC. By substituting and making certain mathematical operations, the value of power flow in case of a resistor is considered as V square by R into minus 2T by RC. V square by R into minus 2T by RC. In the similar fashion, you can calculate the value of the power flow in case of a capacitor. So, power across the capacitor, power flow in the capacitor is given as Vc into I. I know the value of Vc, that is V into e to the power of minus T by RC, as I have calculated it previously. I know the value of I, V by R into e to the power of minus T by RC. perform certain mathematical operations or take some 10 parameters in that common, and the expression for this particular power flow in case of a capacitor is considered as V square by R into e to the power of minus t by RC minus 2t by RC minus 2t by RC. So by calculating the total or complete solution for the current that is flowing in a series RC circuit, I can evaluate the expression for the different parameters that are present across the each passive element that are connected in a circuit. Just I have calculated the complete solution of a current here. What is the complete solution obtained? V by R into e to the power of minus t by RC. By using this particular complete solution of a current for a DC response of a series RC circuit, I have evaluated the voltage across the resistor. I have evaluated the voltage across the capacitor. In the similar fashion, power flow in case of a resistor and power flow in case of a capacitor. Power flow in case of a capacitor. So this is regarding what? This is regarding the DC response of a series RC circuit. We will meet in the next class and we will discuss about this some other combination. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.